Right now, somewhere on Earth, nearly 8 billion people are walking around, complaining about traffic, arguing over parking spots, worried about things that don't actually matter. That number used to be a lot smaller, way smaller than you'd think. There was a point in our history where the entire human species could have fit inside a single stadium. Not a country, not a city, a stadium. And if things had gone slightly differently, none of us would be here at all. This isn't some hypothetical thought experiment. It's written into your DNA right now, whether you've ever thought about it or not. The question is, how did we make it through that? How did a species standing on the edge of total extinction manage to claw its way back to 8 billion people arguing about parking spots? Let's go back to the beginning, the real beginning. Around 900,000 years ago, long before Homo sapiens was even a thing, our ancestors were already in trouble. A team of geneticists, using a new method for reading deep patterns in modern human DNA, found something that stopped them in their tracks. Somewhere around this time, the breeding population of our ancestral line crashed. We're not talking millions of individuals. We're talking roughly 1,300 people for the entire species. And here's the part that should really sit with you. This wasn't a quick scare that passed in a generation. This tiny population held on, just barely, for over 100,000 years before numbers started climbing again. Think about that. 100,000 years of a species hanging by a thread. The likely cause? Climate. Africa went through a brutal shift. Long droughts, freezing stretches, environments turning hostile almost overnight by evolutionary standards. Food sources vanished. Landscapes that used to support life turned empty. 100,000 years is long enough to lose almost everything. And there's a real chance we almost did. But here's the thing about a bottleneck like that. It doesn't just shrink a population, it reshapes it. When your entire species narrows down to a group that small, genetic diversity collapses along with it. Every trait that helped even a handful of those 1,300 people survive got dragged forward into every single one of us. Scientists studying this bottleneck think it may have played a direct role in reshaping human brain development, setting up biological changes that eventually separated us from earlier human relatives entirely. In other words, the reason your brain works the way it does might trace back to a drought your ancestors barely survived. Now fast forward, not to the next disaster yet, to the next decision. Somewhere around 70,000 years ago, a small group of Homo sapiens did something that sounds like a terrible idea. They walked out of Africa, out of the environment their bodies had spent hundreds of thousands of years adapting to and into places with different climates, different predators, different food. Here's the part that should make you wince a little. Genetic research suggests the group that left wasn't large. Some estimates put the founding population for everyone outside Africa today at just a few thousand people, maybe even smaller. That means if you trace back far enough, every non-African person alive today, every single one, descends from a tiny traveling party that could have fit in a few buses. Another bottleneck, another near miss stacked directly on top of the last one. And it should have failed. New continents meant new diseases they had no immunity to, unfamiliar predators, unpredictable seasons. By every reasonable expectation, that small group should have simply died out in a generation or two. They didn't. Fast forward again, tens of thousands of years later, to a disaster with a name most people have actually heard of. The Toba supervolcano. Around 74,000 years ago, on the island of Sumatra, a volcano erupted with a force that's almost impossible to picture. Ash didn't just cover the region, traces of it have been found as far away as India and Eastern Africa, thousands of miles from the eruption site. Some researchers estimate the eruption threw enough material into the atmosphere to trigger years, maybe even a decade, of drastically cooled global temperatures. Imagine losing summer, not for one bad year, for years in a row. Anthropologist Stanley Ambrose proposed that this eruption caused a second severe population crash in early Homo sapiens. A volcanic winter squeezing our species down again, possibly to just a few thousand breeding individuals scattered in isolated pockets. Here's what makes this so important. If that theory holds, it means our species didn't survive one brush with extinction. It survived at least three: a climate crash, a risky migration, and a volcanic winter, stacked across less than a million years. Every single time on paper, the smarter bet would have been extinction. Now, not every scientist agrees the Toba eruption caused a mass extinction event. Some archaeological sites show humans thriving in that same window of time, which complicates the story. But even the more cautious researchers agree on one thing. This was a genuinely brutal stretch to be alive as a human being. So how does an animal with no claws, no fangs, no fur thick enough for an ice age actually make it through all of that more than once. This is where it gets interesting, because the answer isn't we were tougher. Physically, we weren't. Compared to a lot of the predators and the environments working against us, humans were fragile, slow, soft-skinned. What we had instead was something almost invisible in the fossil record: cooperation. Small bands of early humans that shared food, shared warmth, shared information about where danger was and where water was, consistently outlasted bands that didn't. Anthropologists studying modern-day hunter-gatherer societies, groups like the Hadza in Tanzania, have found deeply embedded norms around food sharing that look strikingly similar to what would have been necessary tens of thousands of years ago. Nobody eats alone when the group is starving. Nobody hoards when winter's setting in. Even injured or sick members, people who couldn't contribute for weeks or months, were still fed and protected, because the group's long-term survival mattered more than short-term efficiency. That's not kindness for kindness' sake. That's survival software, running quietly in the background of basically every human culture that's ever existed. Here's the pattern interrupt, though, because it wasn't purely selfless. Groups that cooperated also outcompeted groups that didn't, which means cooperation and competition were actually working together the entire time. You help your group survive so your group can outsurvive the next group over. Feels a little less warm and fuzzy once you put it that way, but hey, it worked. Fire helped too, obviously. Controlled fire meant warmth through brutal cold snaps, meant protection from nighttime predators, meant food you could actually digest efficiently instead of chewing raw meat for hours a day. But fire alone doesn't explain a species clawing back from a few thousand individuals to 8 billion. What actually turned the tide more than any single tool was flexibility. Humans are, frankly, kind of mediocre at everything and exceptional at nothing, except one thing: adapting fast. When the climate flipped from grassland to desert, we changed our diet. When one migration route dried up, we found another. Neanderthals, by comparison, were physically tougher than us in almost every measurable way. Stronger, better cold-adapted, more efficient hunters in their home range. And yet they didn't make it. We did. Researchers studying Neanderthal extinction, roughly 40,000 years ago, point to exactly this difference. Not raw strength, but the ability of Homo sapiens to shift strategies, share resources across wider social networks, and adapt to environments Neanderthals were more rigidly specialized for. Homo sapiens groups appear to have maintained wider trade and contact networks, spreading genetic diversity and knowledge across long distances in a way Neanderthal populations, often smaller and more isolated, generally didn't. Same instinct that helped us survive a drought 900,000 years ago. Same instinct that helped a tiny group survive walking into unfamiliar continents. Same instinct that helped us survive a volcanic winter. Just aimed again and again at a new problem. So here's the full picture. Our species nearly vanished once, 900,000 years ago, crushed down to a tiny population by a brutal, decade-spanning climate shift. It gambled everything again by sending a handful of people out of Africa into total uncertainty. It nearly vanished a third time, possibly squeezed by a volcano powerful enough to dim the sky for years. Every single time what carried us through wasn't strength. It was cooperation, flexibility, and a willingness to change faster than the world around us was changing. And that exact same trait, adapt or disappear, is still the operating system running underneath every single human alive today. Which brings it back to you. That traffic jam you're stuck in, that's a symptom of adapting so well we built entire cities out of nothing. That argument over a parking spot, that's status competition, the same instinct that once decided who got the better hunting ground. You're not separate from any of this. You're the current output of nearly 1 million years of a species that almost didn't make it, figuring out generation after generation how to make it anyway. Maybe that's the real takeaway here. We didn't survive because we were the strongest species to ever walk the planet. We survived because we were the most willing to change. And somewhere back at the edge of extinction, a tiny, struggling group of ancestors held on just long enough to become every single person you've ever met. Thanks for watching. See you in the next video.